Hi everyone, welcome to the Enterprise Manager training series. In this presentation, we will discuss the problem diagnostics, which is one of the core middleware capabilities that helps WebLogic administrators in Enterprise Manager 24.1. So here we have an application administrator who often has to diagnose Java in production environment. But why does he have to do so? That is because the problems happen in production, and he can't reproduce them in his internal environment, and he can't wait for the next planned downtime to fix the problem. Then what are the common issues seen in production? Those can be intermittent availability issues, out-of-memory issues, or could be the application crash or timeouts. And those happen because of the situations which wasn't expected to happen. Then what is the solution for these problems? And there are some requirements in order to run diagnostics in production. First of all, the solution has to be always available. No downtime is allowed because that is the production environment. Therefore, instrumentation of the code or recompiling of the application are not allowed neither. And overhead has to be constant, low, and stable. Impact to the production should be minimal. Wide range coverage, secured access, full range of detailed JVM metrics. And these are actually the features that JVM Diagnostics provide. So JVMD has a solution. Let me briefly show you the JVMD architecture. In high level, JVMD consists of JVMD engine, which is a core analytical portion of the JVMD monitoring system, and JVMD agents, which are the data collectors of the target JVM. And JVMD agents are deployed inside the managed application servers and collects real-time JVM monitoring data. The collected data is transmitted to JVMD engine directly using SSL. So this is a high-level picture of how JVMD works behind the scenes. And JVMD is primarily designed to be able to diagnose Java performance problems in production environment. And because we sample the information directly from the application's JVM and use that information for the real-time analysis, there's no need for you to reproduce the problem in the separate QA environment. It basically eliminates the reproduction process, thus reduces the time to the recovery. Some key features. First of all, it is always on, available all the time. And you can find the problems such as the slowest request or the slowest methods, or the request waiting for the I/O or database, or a request using a lot of resources such as CPU or memory. And no application instrumentation or the recompiling is needed to use this tool. Therefore, no downtime is required in the application for the debugging. And it has constant and low overhead, so the impact to the production is minimal, while having a complete visibility into all layers in JVM stack, such as request, thread, heap, and garbage collections. And JVMD has its own metric management capability, so you can set up a metric, which is JVM specific, and configure a collective action to take a heap dump, for example, upon the metric violation. It also has integration with Java Flight Recorder, or JFR. So you can start the recording of JFR snapshot from EM, or you can configure to take the snapshot automatically at the threshold violations. You can also export the snapshot and import into Java Mission Control desktop application and run any analysis there. JVMD has integration with Enterprise Manager's database performance capabilities. So when you find a particular JVM thread that is waiting for database, you can drill down to find a particular SQL that may be causing an issue. As for the Java Workload Explorer, we'll see in the next slide with more details. Java Workload Explorer. So this is the centerpiece of JVMD, where you can visualize entire JVM stack information, time by resource, and resource utilization. So what I have here in the screen is the Java Workload Explorer homepage. I have a bar chart on the upper side of the screen, and each bar represents a thread that is grouped by the state, such as database weight or CPU weight. So you can see by the color what resource the thread is waiting for. Down here in the table shows the requests that are running in the selected time range. It shows how long they are running, how many times they appear, and the resource utilization information such as memory allocation or CPU. And this table is actually multi-dimensional. So by clicking the buttons in the tab, it displays information for other dimensions. So currently it is showing the requests, but you can flip the screen to show methods, threads, or database resources, for example. Then how can this be helpful for you to diagnose a problem? The core functionality of this tool is that it allows you to compare the workloads. So now you see in this screen, there are two bar charts displayed. And in the table at the lower side of the screen, each column has two sets of data, current and baseline, side by side. So basically, you take a snapshot of baseline workload. And usually, the baseline was the time when the problem was not present, so it's a stable workload. Then bring that onto the screen for comparison. From there, you can carefully analyze what would be the difference between the two. And as mentioned, the table view is multidimensional. If you cannot spot a root cause in one dimension, you can switch the view to other dimensions to find the difference. So in this case, I opened a tab having method information. And here I could see a method present in the current dataset. However, it does not exist in the baseline. This implies a change, and that could be the cause of the slowness in application. That may be enough information for me to go to the developers, but I can further see the call stack to see in which file the particular method resides. Now let's take a look at this in the actual product. Here I have JVM Pool Target homepage open in Enterprise Manager 24.1. This page is a part of the JVM Diagnostics feature. In this view, you can see the deep dive information in the JVM stack. Here is JVM activity. Overview shows the JVM performance statistics, also top requests. Now let's open a Java Workload Explorer from the toolbar. In this view, you can see the workload at the JVM with information on what resource the thread is waiting for, and display them in different colors that can be CPU or database or other factors. And here the purple color indicates it took a lot of time with the network in the recent activities. And this data can be viewed both real-time and also historically by using time slider or using the calendar widget. The lower side of the screen shows more detailed information from the selected time range. Now it is showing active JVMs, but by selecting the icons from the toolbar, you can switch the view to see the different information. Here is a request, and also here was a method that were invoked during the time. And you can see the database information too. So here it shows what database the JVM has communicated and its JVM time, count, and durations. And also the SQL queries executed during the selected time. And you can select an item to activate additional features. Click SQL details, which you can see the actual statement used. And you can further drill down to the database information that punches out to the relevant database target page. If it is also monitored by the same Enterprise Manager instance, you need to enter the database credentials, which opens the SQL details view in the database target. Here's the activity of the SQL, which you see some spikes here. And from here, you can further investigate using database performance management features. This is the end of the recording of JVM Diagnostics in Oracle Enterprise Manager 24.1. Thank you for watching.